Dear students, we are going to see recommender system today in the ideas, and I will share the screen. Yeah, okay. So today we are going to see what is this recommender system is all about. This is like in which we are going to see there are two categories. One is content-based filtering, and another one is collaborative-based filtering. And in this, we are going to see content-based filtering. Recommender system is very important for the user because a user will not know what to take the product if they want to purchase a product. Means they will not know the clear idea or knowledge if they go for one product. What are the byproducts to buy? And this recommendation system will help us even for selecting the movie. It will take from your interest and it will give the recommendation system, right? And if you are going for any purchase, or if you go for a movie, or which one to select, or some music, okay, or some songs, whatever it may be, according to the user interest or from the history information, it tries to give us the recommendation. So that only we are going to see today how we are going to develop the recommender system, right? Okay. So let us see what is this difference between the search engine and the recommender system. Already we are using the search engine. Okay, so you should know the difference. The main difference between the search engine and the recommender system is in the search engine, as you know, you will give some keyword in the search engine bar. Okay, and then based upon that, the indexing algorithm will be functioning at the backend, and it will take that particular keyword and which are all the documents which is present. Which will be stored in the database, and it will take and it will just try to pull the document what we are going to make. Okay, what we have given it as a keyword. So basically, in search engine, we should know some knowledge about it, but in recommender system, it is not so like that. Because we are not necessary to have the prior knowledge of it, the user, and also we are not going to pull. It is not going to pull, but it is going to push. Okay, so that is the main difference between the search engine and the recommender system. So when you look at here, you can see that search engine is like pulling the system that is from the keyword. It will just pick. So it is completely, it's an user initiative. Okay, but here you can see recommendation system is by the system initiative. We are not necessary, the user, it's not necessary to have the prior knowledge about what is required. Okay, it is completely taken from the profile or what we have given likes or whatever it may be. Okay, whenever we go for purchasing the product, it is getting the feedback from the user. All these information will be fetched, and it is going to give the information that is pushing the information to the user. So that's why we can say this is push system, recommender system, but this one we can say like a full system. Okay, and it is user initiative, and this is the system initiative, right? Okay, so in difference, we can say that user knows what is looking for, and he makes the query. So he needs the knowledge. That is the main difference. That is giving him as a keyword. Okay, then only the search engine will work. Until that time, it will be like a stationary. Okay, so if the user gives some keyword, based upon that only it is going to recommend a system. You can see the system generates recommendation to the user based on the past preferences. So without our knowledge, whatever information we are giving, it will be it in a database at the back end. And based upon that, it is the algorithm will be functioning, and it is giving the result for us as the recommendation system for it. So it will guide the user, okay, for the better decisions. So recommender system, again, we can say that it is also and one of the application of machine learning. So you see in the machine learning algorithm, different classification, clustering algorithms and all we have seen, that is supervised and unsupervised algorithms we have seen. And you can see based upon the data set, and from the data set, we have just to find the dependence and independence attributes with that we are predicting. Okay, we are predicting performing the clusters, or either we are classifying from the training model, and we are predicting the new data when it enters. That is actually the machine learning model we have designed with. So this recommendation also one of the application of the machine learning, because here also it is going to collect every information as like in the data set, what the user preference, everything, and it is giving the user as a predictor. If you are buying this, if you buy this product, it will be very useful based upon the interest from the user, or from the profile, okay, or from the click what we made, or from the or from the feedback what we have given. It is going to collect all that thing as the database, or the data set, and then it is giving the decision for recommendation system. So we can say this recommendation system is clearly is the application of the machine learning, right? Okay. So why and when we need this recommendation system? That is also, it's very important. Normally the quantity of the information is very huge in the data set, right? In the data which is already available in the global space. So it is very tough for the user to take the decision. So that's a main usage of this recommendation system. It will just pick the information. For example, people are not able to expert in all these domains in which they are users, and they do not have enough time to spend looking for the perfect television or book, what to buy, and so on, right? So based upon the interest, what is required, okay, that knowledge can be acquired from the user, and also easily it can give it as a recommendation system. So easily we can get the solution from the large amount of the data which is already present, and also it is not necessary for us to think more. Okay, so that's why we can say it reduces the cognitive load on the user, and also it allows us the new items to be revealed to the user. Many thing which is new to us, but in the Google search, we will not give the right apt keyword. But in this, we can get even the new items. So that is the main need for this recommendation system, right? Okay. So we can, how we can classify the recommendation system. One is like explicit and implicit. You can see it as like user ratings, comments, and likes, all these things and all. We are actually giving it by the user explicitly to the system. Okay, so from that records, if it takes, then we can say it is like the explicit, okay, data that is actually using. Implicit means it is like the history, purchase, okay, search queries. These are all the things. It is not actually saved, and it is not can be viewed user directly. So it will be implicitly stored at the backend. So we can say that that type of data, if it is taking for recommendation system, we can say that it is implicit, right? And also two kinds of information again it takes. One is like the characteristics information. For example, what are the information about the items, what keywords we have given, what categories we have selected, and the users, what is their preference, what is their profile, about their age, gender, and so on, right? Okay, so from this information, if we are collecting, then we can say this is like the characteristics information, right? And the another one is like the user item interaction. So whatever interactions, that is, as I told you, feedback, ratings, okay, we have given, and the number of purchases of a particular product, okay, and what given, and what color we have selected. So from these user item interactions, from that, if you are picking the data, that is like another kind of information it will write it. Just we are just classifying the different categories, how the recommendation system getting the information. Okay. So now these are the types of recommendation system. As I told you, one is content based and another one is collaborative based. So what is the difference between it? So content based means based upon from the user interaction, and only from one user, his profile, and the user okay, data interactions. From that we are taking, then we can say that is content based filtering. But on the other hand, collaborative means not only from one user, the related user what they are using. Okay, so collaboratively getting the ideas. Okay, so it will just find out who are all the customers that are all having the same age group or same preferences we made. Okay, so for example, if you are choosing one particular artist, the same artist may be selected by some other customers. So likewise, it will group together and it is going to give the recommendation system for us. So that type of filtering, we can say it as like the collaborative filtering, right? But for our exercise, we are going to do only the content-based filtering. Okay. So in advanced level, they will go for collaborative filtering as well. So you should know the types of recommender systems. Okay. So in formal model in recommendation system, this is how we are giving the formula. That is a C cross S, which gives R. What is this C? So when you take this example, you can see A, B, C, D are all the customers, and the I1, I2, I3, I4 are all the items. Okay, so the different objects. Or here we can say these are all the different uses. Okay, so we can say like C is a set of M customers. Okay, and S is the set of N items. Okay, so that is how we are just saying that C cross S. So this is how we are forming in like the matrix format. And then these are the numbers we have given. What is this number rating? That is 1 to 5. If we just go for a website and if we just click only, okay, we are not going for any specific details for that information. Okay, so that is the time it will just take 1. Okay, similarly, after clicking, if you watch for some time, okay, so you can record the time of how much time you are spending for in that particular website. So watched. So from that, it can be taken it as like a 2. But then the third category, if you go for the Amazon site and then if you go for purchase, then we can go for the third item. And then fourth one, you are giving like, okay, then you are like the fourth category of the item. And if you are giving rating, high rating, then we can make it like as like a, okay, this particular product, he was very much interested to buy. Got my point? So that is the time it may give the rating as 5. So this is how it is just giving the value for it. For the recommendation system for each user, it is going to pick this information for various items. So here the customer A is going for item 1 and then item 4 and item 5. He is not going for item 2, 3, 6, and 7. Got it? Similarly for B going for 1 to 3 and here 4 to 6. And then for customer D is selecting only item 2 and 7. So there are some missing data which is also available. Okay. So with that, we cannot completely take the decision. We have to fill all the unfilled information. So that is also the algorithm will work and filling based upon the ratings which is given in the matrix format, and it will fill all this unfilled also. So that is also the important thing. Then only this can be function. Okay, so that is how the cleansing part also will be done. Okay, pre-processing will be done in order to do the accurate things. Okay, so that is how we are going to check for each and every items, and we are going to study in it. So in reality, the user item matrix can be more than millions and millions. Example, Amazon, YouTube, and all. It's not like a simply like a 7 items, like a simple matrix. It is like millions of rows and millions of columns. Okay, so likewise you can view it. Okay, so there are n of customers will be there. Okay, so we have to develop the best software in order to go for the best recommendation system, or otherwise it will confuse the user. Then that leads to disaster, right? Okay, the goal of the recommender system is to fill those missing entries. So that is a very most important thing for the recommendation system that have to be done. Okay. So coming to here, what is this utility matrix? As I told you, this is the one is like the customer side, and the other side is what all the items. Okay. So system gathering here is like explicitly or implicitly based upon the rating or purchasing. Okay. So likewise and all, it is giving the rating. Okay. So as I told you, simply liked or simply watched or go for a purchase or go for the rating. Okay. Or likewise, when we go to the next level, according to that, the value which is given. Okay, so it's like unknown rating from the known ones. So these are all some of the unfilled one. Okay, so infer will be done in which it is filling, okay, based upon the known ones. From that, ratings also will be filled. Okay, so this will be evaluated using the inference method. That is the main goal of the recommender system, as we saw, right? Okay, so we are going to see about the content based filtering right now. Okay, so as you know, content based filtering, for example, if the user, okay, is going to buy or purchase a product, a cell phone, so that is the time the recommendation system will find out which are all the byproducts that is required. It may be an earphone, or it may be like a wireless or wired, okay, or whatever, USB cable or something else, okay, which are all the things that is required for the mobile, okay, to data transfer, or okay, so, or to hear it in a proper way, okay, for hearing device. So likewise, so many byproducts that is required, okay, for the mobile phone, but the user is purchasing only the mobile. So the recommendation system will recommend, okay, what are the products that is required. Okay, sometimes the same rate, okay, so it will find out the rate. Okay, so it may be given the recommendation system also, the another cell phone with the same rate to the user. This can be the benefit for the user. Likewise, and all same like product, sometimes it will give, sometimes the recommendation system also give the byproduct. What are all the things? If a person buy this, the person also will go for the other items. Likewise, also it will give the input to the user for the better okay, recommendations for buying the products. Right. Okay. So this is like content-based filtering, right? When you see in music recommender system, you can see like one example, right? So the user, okay, one side it takes the information from the user profile. What is his age group, and what is his sex, whether he's a male or female, and what are the items he just selected before, who is, which is the music director or artist, okay, or melody or harmony or rhythm, instrumentation. All this information, what we clicked and what we give the ratings, from that it is clearly getting the information from the user. Okay, so in this you can see that the user selects artist 1 and artist 2. You can see that in artist 1 he selected songs 1, 3 and 4. Okay, only okay, 3 times he selected okay, from the same artist 1. And then in the second thing, you can see in artist 2, he selected only one time the song 2. Got my point? So the recommender system will give the user the artist 1 songs more. Okay, because he likes, okay, clicked, and he may give the feedback or a recommendation. Okay, so whatever it may be. So from the feedback or from the clicked stream itself, it takes the information, okay, and then it will recommend only artist 1. This is how the recommendation system is functioning. Got my point? So it will get the clear study of the user. So this artist 1 and artist 2 is selected by one is by a single user. Got it? And the different songs. You can see that here he selected 3 times with the same artist 1, but for this artist 2 he selected only one song. So easily it will pick the information. Okay, which type of voice he likes, which type of music he likes. Okay, which type of, whether he's liking melody or what type of songs he likes, all that thing, it really, okay, gets the information from the user, and then it start the recommendation system start giving, like, recommend the similar songs by artist 1 only, right? Okay, so this will help the user to easily making it out, or otherwise he have to give a keyword about the particular artist, and he have to go for it. In Spotify and all, you can see, right? Just if you put the year 90s hits of Christian songs or something else, whatever keyword if you put, okay, so, or if you put 2000, okay, easily you can pick the year, and also what type of songs you are just hearing, how much minute you are listening. Got my point? All these things will be clearly understood, and based upon that it is giving the recommendation system automatically. So this is how it is giving easily, we can make it, okay, the system effectively, right? So for that, what are all the steps for content based filtering? Okay, so in the program point of view, just I want to say some of the things. So for our example, I'm taking like a course title. So for example, some courses recommendation will be done. For example, you may do in edX, or you may be doing Udemy, some courses, right? So some recommendation system also will be doing. Okay, so there will be thousands and thousands of courses which will be available. It is very tough for the user to select one after another and making it out. But if you give the keywords, or if you just give the keywords, and it depends upon it, the recommendation system will give. Okay, you have finished this particular course. You do this as well. It will be useful. Like that, it will give the recommendation system will give the suggestions for us. Okay, so how to give this that course title in the attribute in the data set. Just like consider like this course title. Okay, so take course title in which you will have different words. For example, introduction to Python. Okay, for beginners. Likewise, if the course title, if it is like this, how it will take, how the recommendation system will be functioning. Got my point? So for that, what we have to do is we have to take the course title and we have to give it into the lower. Okay, that means what? It have to convert into the lower case. And then we have to give str dot strip. What is this strip it will do? The strip means it will take the spaces which is in the front and end of that particular thing. Okay, so we can say this is like the cleansing part, the cleansing of the particular attribute course. That is the step one. That's why clean the course titles. Okay, so in the front and back, there will be spaces that and all have to be removed, and also first convert the lower case. Okay, so case is very important in selecting the keyword. So, okay, so that's why we are doing first step by giving this particular code to do this. Okay, and secondly, we have to find the term frequency and inverse document frequency to form the matrix, right? So for that, what we are doing actually is, for as I told you, introduction to Python programming for beginners. So here we can see some English words that and all have to be removed. Okay, so like stop words in English. See, for example, introduction to, that TO we have to remove, and Python. Okay, introduction we can take because that is the introduction part, or advanced. We can see the difference. And then Python, that is the keyword we need. Okay, and then programming. Yes, that is the thing it is need for beginners. For is not required. So that English word for can be removed, right? So that is how we have to, that is called actually vectorization. Okay, vectorization means what are all the stop words in the particular title, course title, that have to be removed, that have to be removed. Okay, then only we can do, okay, our thing, or otherwise all the for also will be taken, all the to will be taken, okay, all the English words, okay, verb, everything it will be taken. So that and all have to be removed very clearly. Okay, so that's why we are using this vectorization. Okay, so for this TF and IDF, what is this term frequency and inverse document frequency? How to be calculated? Okay, so for that, what we are going to do is number of terms, number of times term T appear in document D by total number of terms in document D. For example, introduction to Python programming, okay, for beginners. So here, how many number of words, which is uh, a number of terms. So that we have to put it into the denominator. Got it? And then the number of times occur. For example, each and every word after removing the stop word we are taking, right? Introduction we are taking, and then we are taking Python, we are taking programming. We have to check this Python is coming, how many times frequently occurring in that particular course title. Okay, and introduction, how many times it is occurring. Likewise, we are going to fill it. Got it? Because there will be n number of terms will be available. So if we know the different terms without the English word when we are removing in the course title, then we will find out, okay, in this particular document or in this particular title, okay, total number of words, how many, and the total number of frequently occurring words of that particular document, that we have to take it and we have to fill it. Okay, so that is how we are doing this term frequency. Okay, and then when we are doing inverse, okay, document frequency, because these are all the things. Vectorizer is a function, it will be done, but on the back end how it is functioning you should know. Got it? So as a Python programmer, you should know how it is functioning at the backend. We should not say simply vectorization is happening, cleansing is happening. You should know what is happening at the backend. Said you are removing these stop words, and then immediately what it is taking all the keywords which is relevant, okay, for searching, that alone it is taking, and then it is going to the various documents or various titles, and then it will find out the frequency of that particular items. Got it? So that is how we are finding TF. And similarly for IDF, how we are finding out is so like the total number of documents. So for example, course titles, if it is like 1,000 titles means, then we have to put 1,000. Okay, and divided by what we have to do is in the denominator number of documents containing that particular term T. For example, Python, how many times occurring? Okay, so that we have to find out. So logarithmic of the total number of documents. Okay, so it may be 1,000 divided by in 1,000 how many titles have Python. Okay, so that we are taking denominator. Got my point? Okay. So that is how we are just taking it out. And programming, how many times? Introduction, how many times? Then only it will be easy to group, and whether the user needs introduction topic or advanced topic or related to what type of programming. Got my point? So that is how it will be grouped together, and it will give it as a recommendation system for the user. Got it? So for that only we are finding this idea logarithmic of. So multiplying this is for only one document or one title. Okay, how many times it is occurring, and how many number of words in the title, that is we are finding in TF. And IDF is like the total number of titles, so how many times in which that particular keyword, how many times it is occurring. Okay, so likewise we are calculating. In the theory part, you will learn with more examples. Okay, for the lab, I'm just telling you, okay, these are the formulas will be used at the back end to find out the TF, term frequency, and inverse document frequency. Got it? For the recommendation system. Okay. So for example, after this, doing this, we are just applying this TF-IDF feature extraction. Now we have to make it into the matrix format. Okay. See, for example, in this example, I have given course titles. So these are the different title: data science for beginners, Python for data science, advanced Python programming, introduction to machine learning with Python. Okay. So you can see that how many times the Python occurs. See, for example, 1, 2, and here 3. And machine learning, how many times it is occur? 1 and 2, we have seen 2 times. Okay. And introduction, only 1 time we have seen. Okay. And then data science, how many times it is occurring? 1 time. Okay. Beginners, we are seeing 1 time. Okay. But the synonym is introduction and beginners. Likewise, it is going to find out, okay, how we can group together, and this is how the we have to write the code, okay, for the better recommendation system. Okay, so what we are doing here, it is converted into the matrix format. Okay, how we are converting into the matrix format? See, in the column, we are just making it out what are all the words after removing the stop words that will be written. And here, what are all the different course titles? All the course titles will be written it as like a row. Okay, so this is the first row, that is like the first course title, and this is the second course title, third course title, fourth course title, and fifth course title. Okay, and these are all the words we are just finding out. Okay, so we are just putting this formulae and finding out, okay, the number of occurrence of that particular word, okay, in the particular thing. So that is how we are just forming this particular matrix. Okay, so after forming this matrix, what we are going for is step 4 is cosine similarity. Okay, so cosine similarity means between these particular course titles, we have to find the similarity measure. So how we are doing, for example, if I'm going to make it for D1 and D4, okay, so D1 is like one particular course title, and D4 title, and these are all the different keywords after removing the stop words. Got my point? So that and all, it is written is like the different columns, and these are all the different, that is the different course titles. So now we are going to find the similarity between D1 and D4. Got it? So D1 and D4, how we are going to find the similarity means, so this is the formula we are going to use it. Okay, how we are going to do is, we are going to multiply this value and this value plus this value and this value plus this value and this value, multiply, and this value and this value. Likewise, we have to do the summation of each and every value of D1 and D4 of the same word Italian. Got my point? So likewise, I'm just multiplying that. We are going to put it into the numerator, and in the denominator, what we are going to do is, we are going to put the root of 0.075 square plus, okay, point plus 0.16 and 0.075, okay, likewise all that thing, and then again the root of 0.05. This is how I'm going to put it into the denominator. Got it? So this is how I'm just putting this formula for numerator and denominator for finding the similarity measure between D1 and D4. Got my point? So I'm getting some answer. D1 and D4, I'm getting 0. So I'm just putting for D1 and D4 as 0. And again D1 and D4, here also I'm putting 0. This is how I have D2 and D1 and D2 and D1 and D3. Got my point? D1 and D4. Okay, so already we made. So similarly, D2 and D3 we have to make. So when I'm doing all these similarity measure, I have to fill in this particular thing. This is the cosine similarity. Got my point? So we have found out TF IDF matrix. After this, we are just using this particular table. We are finding the cosine similarity. Got my point? So each and every okay, between the different course title, now I clearly know, okay, what is the similarity between it. Got my point? So this is how the cosine similarity we are measuring it. So after doing this TF IDF matrix, the step 4 is cosine similarity, right? Okay. And finally, we are going for creating the course title to index position. Okay. So for that, what we are doing is, we have to remove all the duplicates, and we have to give each and every index to the different course title. Got my point? So that it will not be repeated, and it is also easy for us to pick when we have the index for it. So for that, we are using this formula df.index, in which we have to give the index, that is course title, df of course title, and in which we have to remove all the duplicates. Then it will not be repeated. Okay, with the same thing, it will not be going to check. Okay, so it is going to make it as like a unique, okay, course title, and it is going to make the function of it. Got my point? So these are the 5 steps we have to use for the recommendation system. Okay, I hope you understood very clearly. Okay, so use the code and you can do the recommendation system perfectly.